We begin here with the Advanced Enterprise Solutions Overview, which builds on the topics of the entry unit that focused on the establishment of the basic enterprise network architecture, and presents topics relevant to the development of engineers that are capable of establishing and maintaining industry-relevant business-ready networks. An expanding enterprise business requires much more than just a fundamental network through which the transmission of data is supported. Enterprise networks are expected to support a growing number of services, which involves the integration of technologies that are not native to packet-switched networks. The enterprise network should provide high resiliency from network failure and threats, both internal and external, along with performance growth through the implementation of solutions that optimize data flow. It is therefore necessary that skills be attained for the implementation of technologies that enable an established enterprise network to apply services and solutions that complement ever-growing enterprise networks for true industry application. Upon completion of this section, it is generally expected that trainees will be able to describe the architecture of an established enterprise network, as well as describe the business considerations for enterprise networks. What we have introduced as part of the entry unit has resulted in the establishing of the foundations of an enterprise network to support bare minimum end-to-end communication of data. However, it does not provide a complete solution for business-ready application. This unit focuses on reinforcing the capabilities of the enterprise network to provide a business-ready solution by implementing protocols and technologies that allow such business-ready networks to be established. We represent here a typical real-life enterprise network architecture that is comprised of multiple services and components that represent the growth of converged enterprise networks that not only involve IP data, but also voice and video that require special support to ensure services operate smoothly. The enterprise network is broken down into what are effectively functional areas that manage the different network operations. This includes access for user connectivity, aggregation for traffic flow management, and traffic control through policies that act as the rules for traffic behavior. The core focuses on high-speed transmission of data between networks, and therefore does not focus on decision-making, but rather the pushing of data as quickly as possible. The DMZ represents a neutral domain that allows external users to access various services without allowing them access into the secured internal enterprise domain, and where we may find services including web servers, domain name servers, and mail servers, enabling access to these services from within the enterprise network and remotely. Data centers represent a central repository that provides the storage and processing of data and often houses a number of services which are becoming more and more virtualized over time. One of the major components for data center operations is the need for continued availability of operations. The modular structure of the enterprise network allows for such requirements to be efficiently addressed. The network edge represents the point of entry into the public infrastructure, such as the core of the service provider network, and to any backbone networks used for wide area network operation. Data transmission between the edge and core is often protected by IP security devices in the form of firewalls or security gateway devices to prevent unwanted public intrusion into the core of the enterprise network. Through the enterprise edge, we are able to support remote connectivity to branch offices, as well as implement backup solutions in the event that the primary network fails. The smooth flow of traffic within the enterprise network relies on ensuring both network optimization and implementation of redundancy, in order to mitigate the possibility of failures in the network that may cause hosts to be isolated from the rest of the network and services. The architecture shown here for the core, aggregation, and access layers demonstrates just how this is achieved. Each device adopts a two-node redundant design that ensures that where a node fails, a second node exists to ensure network continuity. The solution represents a balance between redundant design and rising costs that occur as more devices and links are added to the network. The optimization is supported through protocols such as spanning tree that has been covered within the entry-level unit and link aggregation that will be covered later. The enterprise network has over time needed to continually improve its level of security as attacks to the network become ever more complex. It is of great importance to understand that threats to the network can originate from both within the network as well as externally. Preventing threats of network intrusion without consideration of the potential threats that may already exist within the network itself leaves an enterprise network highly vulnerable. As such, a variety of routing and switching-based security solutions have been built around protecting the enterprise network from these forms of attacks. An optimized network also relies on the entire network being operational, and therefore any faults or failures within the network require immediate attention. As the network grows, it becomes increasingly difficult to be aware of the status of the entire network without the use of an automated warning system. Enterprise networks therefore have evolved to incorporate network management station solutions that are capable of communicating with the range of managed network devices to be aware of faults and failures in a very short period of time, allowing response time and in some cases proactive steps to be taken that keep the network downtime to a minimum. One of the big changes to the enterprise is in how many of the software applications, platforms on which these applications run, and in some cases even the network infrastructure of an enterprise is transitioning to be supported through cloud-based solutions. This can be understood as moving much of the services and resources to a remote centralized environment, as opposed to those services being local within the end station or network. The cloud may take on the form of a private cloud, in which the cloud is built and managed by the enterprise domain administration, or through dedicated hosting of storage, platform, services, or software applications by a cloud service provider. Alternatively, public cloud solutions may be used, which will typically involve the same services being hosted, but within the same servers and network infrastructure as with other customers. The hybrid cloud will provide a combination of the two solutions, but faces challenges in determining how interaction of applications between the private and public cloud would be achieved. The concept of cloud begins to shift outside the realm of the immediate enterprise network, and as such is not the center focus of this course. However, it represents a major and critical future consideration that will continue to impact how the enterprise network will continue to evolve. In summary of this section, we just have a couple of questions here. First asking, what is the function of a DMZ within an enterprise network? Well, the DMZ represents a neutral zone of the enterprise that allows both internal and external entities to access certain applications and resources, whilst also ensuring the enterprise network does not permit external entities access to the internal network. What role does the core play in the enterprise network? The core network is concerned solely with high-speed forwarding of traffic between the subdomains of the network. As such, we generally find the core is supported by high-end devices that support high-speed switching.